Good morning, students. Today is the 23rd December 2020. Formation of covalent bond and the ionic bond. Last lecture we have seen about the chemical bonds, the molecular structure, the atom, ion, and the molecule. What is the atom? Atom is nothing but the smallest unit of matter which is indivisible. Here is the helium element which has the two electrons in its orbital. Therefore, see that how that atom it is to be distributed. Electron shells, atomic number equal to number of electrons or number of protons present in its shell. Electrons vary in the amount of energy they possess and they occur at certain energy levels or electron shells. So outermost coverings of an atom nucleus, it is nothing but the electronic shells. Electron shells determine how an atom behaves when it encounters other atoms. So the outermost electron can share for the formation of the bond. Electrons are placed in the shells according to the rules. The first is the first shell can hold up 2 electrons which is nearest to the nucleus, and each shell thereafter can hold up to 8 electrons. The electronic structure which is shown here it is the outermost electron shell can hold 8 electrons. The hydrogen atom which has the atomic number 1, it means in its nucleus there is the one atom, there is the one electron in its outermost shell or that one proton in its nucleus. So the hydrogen, the diagram which shows that one electron it is moving around its nucleus. Second one is the carbon which has the 6 atomic number. So the first of shell which has the capacity to contain 2 electron and outermost shell which has the capacity to contain the 8 electrons. So the 2 electrons in first shell, therefore 1s2, and second shell it is the 2p4, 2s2, 2p2. Likewise the nitrogen and the oxygen atoms, they are to be holding that electrons. Why are electrons important? Electrons elements have different electronic configuration. Different electron configuration means different levels of bonding. As like in a human being, no one is similar to each other. Somewhere else they are having that differences. Likewise, in every element, they are having that different characteristic and the behavior with the electrons. The periodic chart which shows that the elements are having that the similar properties, but in nucleus nature they are to be different one. Electron dot structure. So many times we are to be saying about that electron which is to be showing with the dot. Symbol of atoms with dots to represent the valence shell electron. Again that hydrogen which has the one electron in its shell, so that one dot in its upper side. Likewise that lithium which is of showing that one electron. Beryllium which is of showing that the one electron in its outermost shell which is of there. But that hydrogen, lithium, sodium, in this case they are to be having that one electron in its outermost shell. Chemical bonds, an attempt to fill electronic shell. They are ionic bonds, covalent bond and the metallic bond. Let us see that X dot would be the electron dot formula for sodium, potassium or aluminum. And another is that X5 dot would be the electron dot formula of wishes. So think about it, and which is of showing that X dot structure and X5 dot structure, let us write in your notebook. Ionic bond, the bond formed between two ions by transfer of electrons. The formation of it, ionic compounds result when metal react with non-metals. Metals lose electron to match the number of valence electrons for their nearest noble gas. It means Whenever any element it loses or it accepts the electron, they are tending themselves in a neutral nature by achieving the noble gas electronic configuration. Noble gases are neutral one. Positive ions form when the number of electrons are less than the number of protons. For example, group first metals, they are to be showing the ion which is a first 1 plus, group 2 2 plus, group 13 3 plus. Likewise, the formation of sodium ion, how that sodium ion it forms. Sodium, which is of having atomic number 11, its electronic configuration becomes the first shell, 2 electrons outermost shell, 2s2 2p4, and the remaining 1 electron it goes to the third shell, that is the 1. So 281 is the electronic configuration in a normal sodium atom. When that outermost shell it is of having only 1 electron, but its shell it is having that capacity to 18 electrons. So instead of taking that 17 electrons from outermost, that sodium is always ready to lose that 1 electron and achieve the electronic configuration as like a noble gas. In this case, sodium, when it loses that electron, it carries that a positive charge 1 plus, and therefore it achieves the electronic configuration as like a neon. So the almost 11 protons and 11 electrons in a normal state it is 0, whereas 11 protons and 10 electrons it carries that a positive charge. Likewise, the magnesium ion it is also formed by similar way of a sodium. Some typical ion with a positive charge, magnesium 2 plus in a group 2, group 13 aluminum 3 plus, and group first it is a H plus, lithium plus, sodium plus, potassium plus, etc. Now again that you have to solve if you understood clearly with the electronic configuration. Number of valence electrons in aluminum, how many? Change in electrons for octet. By losing 3 electrons, gain 3 electrons and gain 5 electrons. And ionic charge of aluminum, 3 minus, 5 minus and 3 plus. So which is it? Write in your notebook. Number of valence electrons in aluminum, it is 3 electrons. Change in electrons for octet, it is losing by losing the 3 electrons. And ionic charge of aluminum, it is a 3 plus. Again, you check it out. Give the ionic charge of each of the following: 12 protons and 10 electrons, then 15 protons and 46 electrons, and 15 protons and 18 electrons. So, which is the answer? Write in your notebook. In ionic compound, non-metals in a 15, 16, 17 gain electrons from metals. Non-metal add electrons to achieve the octet arrangement, and non-metal ionic charge 3 minus, 2 minus or 1 minus. Example, fluorine which is of having that atomic number 9, therefore the electronic configuration becomes in a first shell 1s2 and second shell 2s2 and 2p5. So the 5 electrons in outermost shell, when it loses that accepts that 1 electron, the outermost shell it becomes that completed by means of pairing. So 2 plus 8 there is the, it achieves that the neon noble gas element and neutral, become a neutral in a nature. Ionic bond, the bond between atoms of metals and non-metals with very different electronegativity. Bond formed by the transfer of electrons, and it produces charged ions all states, conductors and have high melting point. For example, NaCl, calcium chloride and K2. See here, Na which is of having 1 electron in its outermost shell, and chlorine which is of having that 7 electrons in its outermost shell. So the chlorine requires 1 electron to complete octet, and sodium it want to lose that 1 electron and want to achieve in a neutralic nature, and therefore it forms the ionic bond NaCl. Big greedy thief of dog, that is the chlorine. The sodium atom, the chlorine, where is that electron it transfers, and there is the formation of Na plus and the Cl minus. So there is the NaCl, the ionic bond forms by means of transferring electron. Electron from sodium is transferred to chlorine. This causes a charge imbalance in each atom. The sodium becomes Na plus and the chlorine becomes Cl minus, charged particles or ions. The smallest, which is yellow in color, that is showing in a picture, it is Na plus, and chlorine, which is of having that the Cl minus. Covalent bond, the bond formed by the sharing of electrons, and ionic bond, which is formed by the transferring of electron. The covalent bond between non-metallic element of similar electronegativity formed by sharing electron pairs, and its stable non-ionizing particles. They are not conductors at any state. Example: O2, CO2, C2H6 and H2O and SiC. See the example: covalent bond, which is of having that sharing in a nature. So the oxygen, which is of having atomic number 8. So the 1s2, 2s2, 2p4. So that the 4 electrons, they are to be 2px2, 2py, 2py1 and 2pz1. So that oxygen which is of having that one electron which is unpaired in its outermost p orbital, so they can bond with each other. The bonds in all the polyatomic ions and diatomic are all covalent bonds. Non-polar covalent bonds, when electrons are shared equally, H2 and Cl2, they are the non-polar covalent bonds. So the oxygen molecule, which is of showing that the oxygen atom electronic configuration 1s2 and 2s2, 2p4. Polar covalent bonds, when electrons are shared but shared unequally, as like H2O. So the hydrogen, it is of having one electron in its outermost shell, and whereas that oxygen, it requires that one electron from hydrogen, and therefore there is the formation of a bending in nature. So it happens with the polar covalent bonds, unequally matched but the willing to share. So likewise that hydrogen and the oxygen, it is of a bending in a nature. Water is a polar molecule because oxygen is more electronegative than the hydrogen. It means that oxygen, which is of having that the electronegativity power higher than the hydrogen, and therefore electrons are pulled closer to the oxygen. Metallic bond, the bond found in metals hold metal atom together. Metallic bond form between atoms of metallic elements. Electrons cloud around atoms and good conductors at all states, lustrous, very high melting points. Example: sodium, iron, aluminum, gold and the carbon monoxide. Ionic bond, which shows as like a uh, sheet which is formed by the metals. Metal form alloys. Metals do not combine with metals, they form alloys, which is a solution of a metal in a metal. Examples are steel, brass, bronze and pewter. The formula weight. The formula weight is the sum of the atomic masses. Example: carbon dioxide, carbon plus 2 oxygen, there is the formation of a 43.99. So let us example compute the mass of the following compounds around the nearest tenth and the state of type of NaCl, C2H6 and NaCO2 thrice. Thank you very much. It's COVID-19 coronavirus time. Please take care by using face mask and maintain social distance. Practice properly. Thank you very much.